Justin's presentation today will cover subjects such as why do we need to protect concrete, atmospheric protection from carbonation and chloride ingress, quality control in concrete protection, and an interesting case study displaying the benefits of quality control for owners, contractors, materials suppliers, and applicators. That's enough from me, Justin. Over to you.
Thank you, Kieran. Looks like I gave you quite a mouthful there. Congratulations on getting through it. Welcome to everybody in the audience. Thank you for taking the time to jump online. I'll start by sharing my screen and we'll move straight to the presentation. Oops. And there we go. Looks like everyone should be able to see the presentation slides now. So thank you. Yes, the title of this topic is Quality Inspections for Remedial Works. So what we're looking at is that a lot of our experience is in heavy industry, where those industries such as oil and gas, the mining industry, the shipping industry, wharf structures, things like that, they focus on durability is quite pronounced. And, you know, like we're talking about structures that are either in very aggressive environments or are designed to last a very long period of time, you know, 50 years or 100 years. So their focus on, well, their budget for durability to begin with is large, and their focus on durability is strong because they know that they save money when they get things right first time round. But our experience in those industries has shown that if we can apply those same methodologies to commercial construction or civic infrastructure, and without overbaking it, without doing the full gamut of the whole quality control process, we can take just the key concepts and apply them to commercial construction. It benefits the whole supply chain. And, you know, using an independent inspector provides that technical assistance and also will focus on making sure that you have inspection for the quality hold point within the inspection test plan. And we'll describe how that provides assurance to not only just clients, but contractors and suppliers also. So Kieran mentioned our agenda. So it's, you know, we'll start off talking about why protect concrete, and we'll talk about extreme examples of where concrete needs protection, and then bring it back to atmospheric protection of concrete, which is kind of more in the commercial space and civic infrastructure. Then start focusing on quality control in the protection of concrete, and then we'll display a case study where we can show how each entity in the supply chain can benefit from good quality control. And at the end, we'll have time for some questions, as well as provide a link for some free downloads. So just a reminder that as I'm going through the presentation, if you've got a question, please type it in the chat box and we'll pick them up at the end. But you feel free to put them in the chat box at any time throughout the presentation. So protection of concrete. I mean, concrete on its own often survives quite well. It's really, when we're talking about protection of concrete, we're thinking about either through applying a barrier on the outside, so waterproofing, protective coatings, or managing the corrosion of the reinforcing steel through corrosion inhibitors and cathodic protection. But not all concrete needs that, right? It's really, when we're talking about those strategies, we're looking at something whereby it's a high corrosivity zone. You know, maybe it's coastal, or maybe it's exposed to chemicals, or something that is not going to be accessed easily again. So when cracks develop or spalling occurs, you can't deal with it. So instead, the designer should make sure that there's that higher level of protection to begin with. So there's less chance of cracking, less chance of spalling, or for an increased service life, whereby the structure's intended to last more than 30 years. If you want something to last, 50 years, 100 years, you need to start looking at these additional layers of protection. So that's just a focus on where we're at with in heavy industry, really. And if I take you to some extreme examples, I just want to highlight, if in the nuclear industry, could you imagine trying to protect concrete in the nuclear industry? So in a nuclear reactor, you have wastewater, and the whole reactor is encased in concrete. It needs to be resistant to radioactivity. That's the thing that wants to break down organic molecules. It also needs to be chemically resistant. So if you own a nuclear reactor, if you want to sleep at night, you're going to make sure that thing's done right. You're going to have clear specifications. You're going to pre-qualify your contractors. When the work's taking place, you're going to make sure someone's there to inspect it. And you want all the documentation to make sure that there's a paper trail saying everything was done right. You're not going to wait for a defect to occur and rely on a warranty, right? You're going to get it right the first time. Another example could be seen in the mining industry, for instance, with their wastewater. Their wastewater is contaminated with heavy metals and strong acidity. And perhaps in a tailings dam, they may have a clay base with a liner, but on the dam wall, it may be a concrete wall. So the concrete needs to be protected from the contents of the dam, from the aggressive environment. So again, linings and impregnations and mixtures and things like that need to be applied to protect that concrete. Because we've seen around the world tailings dam failures where the dam wall breaks and it's flooded townships, it's wiped out townships. So these are the extreme examples whereby if you want to sleep at night, you've got to make sure you get everything right. And so that's where these durability lessons in heavy industries come from. So I've used this chart to sort of break industries into different levels of requiring quality control. Down the bottom there is the most extreme sort of examples of structures: acid bunds, tailings dams, nuclear industry, coal-fired power generation. The industries that below that, that with slightly less is kind of where we spend a lot of our time in assessment and inspection. In the wastewater industry, on bridges and wharf structures, and maybe a little less time on industrial floors and manufacturing, but it's in that line because they really benefit from having that level of quality control. Moderate is where we have car park floors and noise walls. Only occasionally do they get quality control applied. When I say quality control, I mean that external additional layer of quality control. I'm sure the contractors still do their own quality control, but that's quite different. And then general construction has the least amount of independent inspection. So, I mean, I've been giving examples, these extreme examples, but my point is I'm trying to describe how the row that says most and the row that says moderate can benefit by applying some of these key principles. So we know not all concrete needs protection. For example, here in the image, the prefab concrete panels that are being installed on a commercial building. You know, they just need decoration. They don't need protection. The image below, my new mansion on the beach at Byron Bay, that doesn't need protection. It needs decoration. Anything that's designed for less than 30 years, durability, concrete will stand up quite well unless it's seriously aggressive environment. But if we're bringing our focus from the heavy industry back towards civic infrastructure and even commercial construction, we're thinking about atmospheric exposure of concrete. So not the tailings dam, not the nuclear reactor, but more bridges and structures and wharves and piers and things like that. So in those structures, the major degradation mechanism is usually carbonation or salt ingress. Now, carbonation it's the process of concrete reacting with atmospheric carbon dioxide. It's the concrete starts at a high pH value, which is very alkaline, and then over a period of years and decades, it slowly loses its alkalinity. The pH drops, and when it drops down towards 9, somewhere around there, the steel is not passivating itself. The steel will protect itself in highly alkaline concrete. But when we lose that alkalinity, the steel loses its passivating layer. The concrete's fine. It loves it. It's the steel that doesn't like it, and it starts corroding. And that's one of the major issues we deal with. Coupled with that is where salt enters salt can migrate through the concrete and find its way towards the steel. And whether the concrete's high pH or if it's carbonated, it doesn't matter. The salt will still interrupt that passivating layer and cause corrosion in alkaline concrete. If the salt migrates at the same speed as carbonation, it just means when they both get there, it's going to be very aggressive corrosion. So in dealing with carbonation and salt ingress, there's a range of different methods that can be employed to protect the concrete. And that includes at the design phase is including concrete admixtures in the mix. Cathodic protection can be applied, but usually in the early years of a structure, if the designer puts some tags and probes in there, you don't need cathodic protection, but the tags and probes enable you to monitor corrosion of the steel. And then, you know, down the track, when you need to apply corrosion protection, you know when it's due, whether that be in 5 years, 10 years, or maybe 15 years, you can start applying cathodic protection to make the structure last longer. Corrosion inhibitors can be applied within the admixture, but also later through migrating corrosion inhibitors. So it's a solution you put on the surface and migrates through the concrete. And we can also use cementitious polymers to waterproof the surface. So they provide a barrier on the surface. So do our polymer coatings such as epoxies and polyureas provide a barrier to separate the contaminants from the concrete. So each of those strategies, when maybe just focusing on providing the barrier with the waterproofing or the polymer coatings, that can also be used to stop carbonation in concrete. It seals the surface off from the air. So it is a relatively basic process, but it still benefits from quality control. The problem when we say something's basic or something's simple, all of a sudden nobody pays it any attention. And that's the problem. And an anti-carbonation coating is important. So even though it's relatively easy to apply, it's important. So it requires, it can benefit from external quality control. And it doesn't need to be expensive. It doesn't need to be a lot of work. It just needs to be making sure that the surface preparation is done properly, that the primer is applied, and then the coating is applied to a proper thickness and has proper film forming characteristics to last 10, 20, 30 years. So just a couple of inspection steps on the inspection test plan helps make sure that that process is taken care of properly. Same as your migrating corrosion inhibitors, and it's like silane treatments. 5 minutes after you apply that stuff, you can't tell it was put on. The concrete looks the same as what it did before. So the only way you can really prove that it was done properly is that it's documented. You know, somebody's there to witness it being applied. They're reporting that the surface was prepared properly to accept the treatment, as well as the volume and the spread of the material. Using these materials, it's all about the corrosion inhibitor migrating towards the steel. If you don't put enough stuff on, it doesn't get there, or there's not enough of it. So that needs, again, relatively simple process, but it's so important. It requires an external level of quality control. Just a couple of simple steps on the inspection test plan can take care of that. Just a word on product data sheets, and I'll also talk about warranties, because these tend to be a couple of things that people trip up on. Product data sheets are written with good intentions of the manufacturers, but they're a generic document that try to describe the whole range of concrete protection, you know, from the residential decorative level through to commercial construction, right through to aggressive environments. And they're trying to communicate to that whole range of industry. So the information that's in a product data sheet is consider it base level, and it's really something you need the experience of the product manufacturer to provide further information, and then also consultants to build specifications around that. So now I'm just going to focus on a particular project and just show how different levels of project management, how different levels of how people up and down the supply chain can benefit from the external quality control. In this example, on the top right-hand corner, you can see this, it's a sewerage concrete tank, a square tank, or oblong. The wall at the top right corner, that's heavily scoured. After it's been cleaned, you can see all the cement matrix is dissolved away, and you're left with that bony concrete with the aggregate hanging out the wall. So that's reduced the thickness of the concrete. It means that the steel inside the concrete is closer to the surface. There's not much concrete protecting the steel. So in this project, the requirement was to build up the thickness of the concrete using repair mortars. So you can see the image in the middle is where they've applied panels of mortar to about 25 mil deep. And there's a gap there where they've pulled the batten out, and you can see what the aggregate looked like, what the wall looked like before they started. And the image at the bottom is where they've, once they've completed all the panels, they've stitched them all up, and they've closed up that gap where the battens are. There is an image in a later slide that shows the finished wall surface after waterproofing, but I'll just focus on this example for a moment and describe that the benefits of quality control are obvious to the owner. I mean, they get somebody that's you know, that's experienced in concrete repair and coatings, that is focusing on their job, and somebody that's independent that can give a independent opinion of different things. So the owner can also, the purpose of this whole thing is to increase durability, right? You don't want to keep going back into that tank and you don't want the mortar to fall off to begin with, but I mean, even if it almost worked and it lasts 10 years instead of 20 years, that's still a problem. You don't want to go back there in 10 years. You want it to last as long as possible. So by having independent quality control, that means that each step of the process is managed and doesn't pass until it meets the requirement. Another advantage, or an extended advantage of that, is that studies show 15 to 35% of the cost of corrosion can be saved through gaining better durability. And that doesn't mean new technologies or things that aren't invented yet. That means that with everything we have today, if we just do things better, you can save 15 to 35% of the cost of corrosion. You could probably consider, you know, that is a fair portion of a maintenance budget, really. For the head contractor, the benefits are that somebody is there witnessing, marking up areas that need repair, witnessing what work is taking place, and also recording when things are completed satisfactorily. So they know that their subcontractors are well managed. For suppliers, material suppliers, when projects don't go so well and something fails, you know, obviously the contractor gets it, but also the product also gets blamed as well. You know, people say, oh, well, that product fell off, you know, but it's not always a materials problem. Sometimes it's an application problem. But if something goes wrong, everyone starts to smell a little bit. So for suppliers, knowing that there's an independent person there, it gives them more assurance that their products are being applied properly and that they're going to get great results. The image here on the bottom right corner is the final image of that tank, where cementitious polymer, the waterproofing, has been applied over the top. So you can see that the tank is in much better condition than what it was to begin with. And the graph there is an ultrasonic image of how we can measure the thickness of the waterproofing. So we're able to measure the waterproofing over the top of the mortar. So in this example, it's 2,085 microns thick, which is basically 2 millimeters of thickness. Using that technique, wherever we find low spots, we can have those areas reapplied and have extra thickness applied. For the applicator, the subcontractor, they also benefit. And quite often we go onto a new job and the applicator's like, oh, wow, what's this? These people are going to watch over my shoulder. They're going to check my work, you know, and they're a little apprehensive. But within the first couple of days, every job we're on, the applicator soon realizes that we're of benefit to them. They've got somebody that's experienced on many different projects, observing what they do. And the intention is that if something's going astray, is that it gets picked up early. Applicators love it. They're like, they save time and money when they identify issues late. That's when they have real cost problems. Then also knowing that somebody is documenting and recording the project, a project that's going well, the report is a glowing endorsement of that job. So that also helps protect them from warranty claims. Then there's some images of some different jobs we're on, witnessing mortar application, as well as testing concrete and concrete coatings. And if you jump onto our website, you'll see there's some free downloads there that you're welcome to collect and share. And I'd just like to leave you with a last few thoughts on how to succeed on concrete jobs, you know, whether it's protection or repair. it's don't rely on warranties. If you're a project manager and you're relying on warranties, if you need to claim on a warranty, it means you didn't manage quality control properly, and often you'll never get back to fix it right. You know, by that stage, the asset's already been put into service. Maybe they're not going to shut the asset down and give you proper access. So you need to use secondary repair methods that are always a compromise on the original level of quality. You may have disputes where the contractor says, well, it's not my fault, it's the material's fault, or the material guy says it's not their fault, it's something else went wrong. So maybe you can't claim on your warranty. Nobody fixes it. So don't rely on warranties. Manage the quality control early, and then a couple of these key strategies throughout the project, and you're done. You're going to have the job you need. For asset owners, when you're managing your projects, start early, and I say build a register of condition assessments. We can get in, just a one-day inspection to check out a part of the asset, build a report around what the degradation is and what the repair strategies could be. Then you can budget and allocate that to your maintenance plan. And so if you build a register of these condition assessments, it helps build out your maintenance plan. And then later on, when each condition assessment becomes a project, then we build a specification around it. And that's the document you take to market and have applicators quote against that. That becomes part of your contract document, because that's what we hang our quality control on later. That's when the job when you engage the contractor and we're starting work, that's what we build the inspection test plan against. That's what we do. That's where we allocate the independent inspections. So that document's very important. So these are the key things to think about in your projects, and that will help you succeed. And like I said, external quality control need not be a costly duplication of your services. Durability is a small part of the development plan. And so, independent inspection should really be focused on delivering value without excessive cost. You can implement these strategies without massive cost. So, I'd like to thank everybody for your time today, and thank you for listening to me. We might have a little bit of time for questions and answers, so I'll close out and hand over to Kieran.
Thanks, Justin. Yeah, we've had a couple of questions come in during the talk. One of the earlier ones was, when we consider mass concrete is a highly durable product, if we think about historical structures and Roman structures being built 2,000 years old. If we can get rid of the steel inside the concrete, it'll probably make everyone's life a little bit easier. So the question was about, what's been your experience with the take up of polymer or fibre reinforcing as a solution in the concrete? And have you seen much of it in the industry?
Yeah, look, to be honest, I haven't had much experience with it. I've seen a couple of technical presentations from other people about it. So I can't really speak to that to a great deal. I won't waste time. Thank you.
Have you seen much uptake in the work you've looked at in the newer structures?
No, I haven't. I mean, the focus is what I've seen. The focus is on heavy steel, lots of concrete, and then protect the surface.
All right. So in relation to surface strength, so in a benign environment, what surface strength range in regards to pull-off testing would be adequate to apply a coating to prevent further concrete deterioration?
Good question. So we're talking about the tensile strength of the concrete surface.
Yep.
So we can do pull-off tests to ASTM standards and various other standards. So the coating needs to hang on the surface. It needs to anchor. and it has a certain weight to it, right? You start coating something in 2 mil of thickness, the drums of paint that you're carrying to site, all that's going to hang on the wall when it's cured. We're talking about hundreds of kilos or even tons of paint or cementitious polymer. So you need good surface. The surface needs to be strong enough to hold that together. Otherwise, the weight of that material will pull away. So short answer, somewhere around 2 MPa on a 50 mil dolly, sometimes getting down to 1.8. But yeah.
In regards to surface finishes, so do you have any recommendations on the finish standard for concrete where we can obviously potentially eliminate or minimize the need for fillers before coatings?
No, I mean, we have coating standards that talk to that and talk about filling air voids and taking latenants off and things like that. The SSPC SP series, and can't think of the number off the top of my head, might be 15, is a good standard as well. Yeah.
From one of our viewers in Queensland, embedded devices in concrete, do they create a corrosion issue?
Oh, well, embedded devices is in monitoring for corrosion, I'm imagining.
Yes.
Yeah. So, well, preferably not. I mean, they're there to connect your wires to so that you can measure the corrosion of the steel. So applied properly, no.
And in regards to surface prep, question just come in. For concrete predominantly based on applying the right primer on a clean and sound surface, or does it require a specific surface roughness akin to steel surface prep?
Yeah. So it depends upon the coating you're using. Typically, the thinner film coating requires less profile. A thicker film coating requires deeper profile. It gives it more mechanical anchor. But we're definitely looking at, we don't even talk about acid etching. We just throw that out the window. We go to ultra high water pressure or concrete grinding to take the surface back. Then if you need further profile, it's wet abrasive blast cleaning, really. So there's the ICRI standards, the International Concrete Repair Institute. They have great replica chips that you can use and hold against the surface, or many specs will reference a different roughness of sandpaper. So you can buy sandpaper, 60 grit sandpaper from Bunnings, and you try and compare the surface to that sort of roughness. That's what we're looking for.
Look, I guess as a general, always remove that surface latence from the concrete. That's got to be a...
Oh, yeah.
I think as a guy coming through as a contractor when I was younger, that was something that took a long time before anyone ever pointed that out.
Yeah, I agree. I mean, it's easy to place this high level of quality on people that are still learning through the industry. And we've all come from a place whereby we've learnt along the way. So it's a credit to that gentleman to actually be aware enough to ask the question. So latenance, definitely, it's got to come off the surface. It's just that dry, friable, dusty layer. Nothing wants to stick to it. If you're using a migrating in corrosion inhibitor, it's going to block the migration of that material.
Your experience, or maybe there's some case studies in the link with regards to sulfuric acid attack on concrete?
My experience, sulfuric acid, yeah, I mean, it's one of the worst, one of the strongest acids, depending upon concentration as well. Sulfuric acid depends if it's being stored as sulfuric acid in a tank. So you have a bund around it that's probably concrete. So that really needs a strong vinyl ester coating, very chemically resistant coating. If you're thinking about hydrogen sulfide, you know, like a sewer environment where the gas creates a weak sulfuric acid mix on the surface, then high build epoxies and geopolymers can manage that. And there's a range of different methods to protect that surface.
Shrinkage cracks. Are they an open door for salt and corrosion? Salt attack onto the steel ring. Hold on one second.
Yeah, I mean,
onto the steel. You're right. The question's just finished coming through.
Yeah, you're catching up to the question.
Yep.
So, I mean, let's take it out to a wharf structure, if you like. So, concrete structure over the top of a sea body. When they're designing those things, they don't build them for 20 or 30 years. You know, you don't go replacing a wharf every couple of decades. You build it for 100 years.
Yep.
And so it's all about keeping the salt out of these things. So they'll be looking at the concrete mix and making sure it's dense, so that, you know, carbonation is very slow and progress of salt migrating is very, very slow. And then you can even seal the surface off just using, you know, again, I use that word basic coatings, but maybe single pack coatings. Anything you can do to provide a sealed surface, and then beyond that, provide a barrier on top through coatings and geopolymers, is going to stop salt migration. So, but the reverse of that, anything that's a crack, anything that's a void, you know, soft concrete is going to allow the transmission of chlorides. Yes.
That's the sort of the end of all the. I'm going to check our last questions.
There's one there about the building code.
Yeah, it's in the chat. Yeah. So can you briefly touch again on how corrosion is managed within the building code?
Yeah. Thank you. It's a bit of a passion of mine, actually. The building code is not great with corrosion in any sense, whether it's on steel or concrete. And in fact, when I've been involved in some failure, some expert reports for failure analysis, I've taken a look at this, and most structures require a 15-year design life, and I'm probably a little focused on Victoria here. 15-year durability till maintenance. I mean, it doesn't mean it's going to fall down in 15 years. It just means that it's going to need maintenance after 15 years, which isn't great. I mean, even if I'm building a house, I'd like to think 15 years, I want more than 15 years. But the building code talks about the structures, the structural steel, the concrete, the structural concrete. It doesn't talk about the corrosion protection method. So the coating or the cathodic protection, it calls that a maintenance item. So that's the problem. A construction company isn't, I'm not saying they're doing the wrong thing. I'm just saying they're following the building code, but when it comes to corrosion protection, they're not asked to focus on it, and so they don't.
Yep. With regards to coatings on reinforcing steel before it's placed in the concrete, I mean, the discussions I've ever had about that, it generally swings around to that if you build the thing properly and have sufficient cover, you don't need the coatings on the steel. But I mean, have you come across any sort of where it's a we should be doing that?
Yeah, I mean, the flooring around a petrol station typically has extra protection for the reinforcing, whether it be galvanized reinforcing. I've only been on a couple of projects where they've used stainless steel. I think that I agree with you, Karen, that if the concrete does work when we place it properly and we protect it properly without the added cost or having compromises with different types of reinforcing.
Yeah, I guess it does come into play when we're repairing structures and there's no chance to put that cover back. look, I think on some projects it works out more cost effective to cut out what's there and replace it with a galvanized bar, as opposed to trying to prepare and coat what's in there.
Yeah. Sorry, I think I misread the question then.
Column bases. So where we have that connection between floors or wherever we're pouring a new column, is there a recommendation for a sealant, for any type of sealant at the steel to grout when we're grouting column bases?
I can't think of a good one there. So a concrete column or a steel column?
I'm reading this as I imagine this is grouting a steel column.
Oh, okay. Yeah. The steel, definitely, if it's a normal atmospheric or interior exposure, a galvanized steel column will work fine, and bed the mortar underneath that. If it's a mild steel column, or maybe it's a more aggressive environment, I'd look at putting a coating under the base plate and even up over the top of the base plate. Yeah.
And I guess maybe just thinking about that now, if it's a concrete column going in and where you've got your starter bars coming through, we do end up having a bit of a cold joint between the element and the column.
Yeah.
And usually just some mild steel starter bars sticking out there. So what's your recommendation in that?
Yeah, definitely. A flexible polyurethane really works well there, like your waterproofing product.
Yep.
Just to bridge that cold joint. So yeah, 100 mil either side, 200 mil either side of the cold joint.
I think we are done in regards to questions. I've got nothing else that's come through. That was the last. Okay. We're done. Thank you very much for your time, Justin. That was a good insight. I guess, before we go, I just thought of something now. Have you found much, I guess, with the client side QA consultant isn't, I guess, in a lot of industries, in a lot of parts of our industry, common. Have you found sometimes the contractors starting to rely on your inspections as the quality control as opposed to the quality assurance, sort of hoping that the guy from Remedial will turn up and hopefully pass what we've done as opposed to doing their own? Have you experienced that?
Absolutely. And it's, I mean, in an ideal world, I'd like to say we're quality assurance. So the contractor is managing his own process. He should check each stage of works, and then pretty much put your hand on your heart and say you're proud of the work. Then we'll come and check it. And that's the perfect example. But often our range of experience tends to be very broad, and we are focused on quality. We're not focused on scaffolding and everything a contractor's got to think of. So sometimes we're the most knowledgeable person related to quality. And so for the benefit of the project, we need to take on the dual role of quality control and quality assurance. So we do the testing. Yeah.
In regards to, so we touched before on repairs where there's low cover and we can't go and reinstate that cover. What sort of coatings then is there out there that we could use to sort of give us some protection in those areas? We can't have where we've done a concrete repair, we can't have a bulge on the side of a building to reinstate the cover. So what are some of the options we've got there on the steel? Yeah,
sure. So a couple of things. You don't always have to reinstate cover. If it's a water retaining structure, typically there are standards that require minimum cover. So then you kind of snook it a bit there. But on other structures, it's all about protecting the concrete. Protecting the reinforcing steel. If you can't build cover, you can provide a barrier. Cementitious geopolymers or our polymer-based resins, epoxies, polyureas. As far as the steel on a repair, when you excavate back and you need to get back, you know, say an inch behind the steel, so you can treat both sides of the steel without pulling it out, and you need to clean that back through ultra high water jetting, or even wet abrasive blast cleaning will help take the corrosion off, and then treat it with a zinc primer. After that, it's ready for you to start building your repair layers.
All right. There were a few last minute questions that came in, but I think this time we're done. That's it. We are good. That's all the questions done. Thanks again, Justin, for taking the time out and giving us a bit more insight into that part of the world.
Thank you. Thanks for the opportunity, and everyone in the audience, thanks for participating. And you know, if you need some more information, just jump online and hit me up through our website.